Right now we're having Amit and Aditi about to join the stage. Are you guys with us? Amit, Aditi, hello. Can you hear me okay?
Yeah, I
Yeah.
can hear you okay.
Awesome. Guys, take it away. I will be back in 15 minutes, and we're going to have a bunch of questions from the audience. I'm sure we're going to have about 5 minutes of time at the end to ask you guys those questions. And looking forward, very excited to hear what you guys have to share with us today. And take it away.
Yeah, thanks, Adam. So, hi everyone. I am Aditi Pandit. I'm a engineer at Ahana IBM now, and I'm also joined by Amit Datta, who is a software engineer at Meta. And we're going to talk today about the Presto C++ engine, which we sort of built in open source and is now available at IBM watsonx.data and Meta production. So, in terms of this talk, we'll start with a quick introduction to Presto, and I'll give some background about the Presto native engine, the C++ engine, what it is and why we're doing it. Just a quick introduction to what's the next data platform and the Presto native engine offering on it, and then Amit will take it over and talk about the production experience at Meta. So, introduction to Presto. So, Presto is a fast and reliable open source SQL query engine for data analytics in Open Data Lakehouse. So, this project started at Meta over 10 years ago and has since expanded its reach at like big data companies like Uber, ByteDance. And if you look at the numbers here, they're like massive. And this engine is built in open source. And if you see in terms of the ecosystem, it's a distributed SQL query engine that sits between the underlying, it could be DSAG storage on S3. Other cloud stores, or like just regular databases. It's a federated query engine, so it can query many systems. And at the higher levels, you have your tools, Looker, Superset, that can be used to submit queries to the Presto engine. And this system is massive. Um, it has a very vibrant open source community, both in terms of users and contributors. And you can see a lot of like very cool logos here: Meta, Uber, IBM, Bolt, ByteDance, Twitter, Alibaba, you name it. Um, so going to Presto native engine, what and why? So around 2020, all the teams using it sort of realized that the use cases that Presto was being used for, in terms of like very advanced analytics, machine learning, on data lake houses, more so. The Java worker was kind of reaching its limits in terms of what it could do for those. And this led to the team sort of working, kind of going to this in this direction where a C++ query eval was desired. And this system is built with like first class vectorization, runtime optimizations, inbuilt memory management, and this gives us a lot of amazing things for our current use cases. And this was sort of in line with similar initiatives. There's Photon at Databricks, Intel and Meta started Gluten for Spark acceleration, and this sort of went in line with a lot of what was going on in the industry also at the time. So, what is Presto native engine? It is a full rewrite of the Presto worker in C++. So, it's a drop-in replacement for what was the Presto Java worker, and it leverages Velox. So, Velox is another open source project started at Meta. Velox is a library of like data processing primitives and inbuilt memory management. So think about like hashtag, joins, windows, all these things are provided by Velox. So to sort of just show at a very high level visually, like kind of what's going on here, um, you have the Presto cluster, which is shown on the left-hand side. So a typical Presto cluster has a coordinator. It talks to a Hive metastore for table information, petition information, but the main workhorse are these worker engines. So you can have multiple worker nodes in your cluster, and these worker nodes do all the reading, execution, exchanges between workers to make your sort of query happen. So if you notice, there is a control API and a certain data exchange API that the workers have to honor to interact with the coordinator and between workers for exchanges. Now, in a Java based system, there were a lot of limitations and inefficiencies. So there were GC pauses, performance cliffs, operational difficulties, hard to control performance. And so we just flipped to an architecture which looks exactly the same, except that the underlying executable for the worker is flipped to C++ executable. So that's just what we do for migrating your clusters. The Prestissimo worker talks the same control API and data exchange API as the previous system, and so by just dropping in the C++ worker, all this works. Um, the C++ worker leverages SIMD, runtime optimization, smart IO, prefetching, caching. It's got a lot of cool stuff that kind of gives it a big edge. So Velox at a glance, this is what is used by the underlying engine. So like the task fragment, which comprises SQL, a part of the SQL execution is given to drivers, which set up pipelines, operators. You see all the operators for join, ag, the exchanges on the left-hand side, and there's a massive inbuilt memory management, which comprises pools, memory manager, that sort of is used in the rest of for the operators. So, what are the advantages of Prestissimo? It's like a huge performance boost, avoids performance cliffs, and because of Velox, we were able to build reusable and extensible primitives. Velox is also used in the Spark implementation, Gluten most notably. So just to brag about what we were able to achieve, we did a whole lot of TPCDS workload at IBM. And here are the results. So if you see for a 1K run, native engine did almost 3 times better as Java. So the blue is the Java run, red is the native run, and you can see that the native numbers are good all throughout. At a 10K, we did almost double as well. So the native finished in 2 hours, whereas Java took almost 4 hours. And again, better numbers all across the board. And the most amazing thing is that we were able to do a 10K run in like less than 4 hours, and Java was not able to do this at all. So this gave us like amazing improvements. Um, and in terms of what you can do with watsonx.data, so watsonx.data um, is a platform data to build data lakehouses. It's for enterprises, and it sort of is built on the concept of it has openness at all layers. So it many engines are available for the user to set up. These engines work. So if you see the left hand side, those are all the layers of the stack. You have the engines at the topmost layer, and they work with open table formats like Iceberg, uh, Delta, Parquet, and we have a metadata store which is like Hive compatible, and your underlying storage could be any like cloud store or the legacy query engines, and the infrastructure is based on Kubernetes, so this works on hybrid cloud. So I'll kind of stop here and hand the stage over to Amit, who will be talking about the Presto Native engine at Meta and where they've got there. So yeah, take it over, Amit.
Yeah, yeah. So we'll be talking about the native engine in meta production. Next slide. So roughly, this is the history of Presto inside Meta. So in 2015 to 2017, we were working for Hive migration and external analytics when Presto was initially launched. In 2018, 2019, in this time period, we were working on interactive and batch workload, and also the Presto project was donated to Linux Foundation at this time point. And in 2020-21, there was a lot of work in caching, making Presto work in elastic compute, and the efficiency work was started. And after that, from 2020 on, we started working on the native execution. Next slide. uh, in Presto in at Meta is used for many various kind of workload. uh, It has internal functions, external functions, internal connectors, and the wall times of these workload can be from few seconds to few hours. They can be periodic workload, ad hoc, slice and dice, and machine learning workloads. There are different kind of writers, exchange operations, and there is a strong. We had strong need for faster execution, and supporting those with limited hardware, and when to keep the customer expectation as well. Next slide. So we also had many evolving requirements like machine learning file formats, uh, and then we had requirements to make SQL on machine learning file formats similar to general file format, and we want to do it in the same deployment with the regular Presto and new formats. Next slide. Uh, so in Also, one of the important part of Presto was the correctness, the performance, and the release and deployment. Uh, when we are migrating Presto to the Presto C++, because this is a Presto is already running as one of the major engine in Meta, and while changing it, we need to make sure that it's function as good as Presto and making its promises. It's almost like changing the engine while the plane is flying. Next slide. But Pesto has almost a decade worth of fixes and functionalities, and it's the source of truth for all competing platforms within Meta. And there is a backward compatibility of results within Presto. So when we are developing Prestissimo, one of the major challenges was to make sure how this is correct, and how can we make the verification strategy. So there is a wide variety of workloads, and there are deterministic, non-deterministic workload, and same query defined parameters, retrievable, not non-retrievable workload. And with Prestissimo, there are different libraries that got introduced, like JSON parsing, regex libraries. We had to work many stages to make sure this we can replace Presto with the new engine. Next slide. And then uh, the main driving point for the complete rewrite was to make sure the performance metrics are really good. And in this case, we take the performance by taking the summation of the CPU time or execution time for Presto Java eval, and we take the summation of all the CPU and execution time for the Presto C++ eval, and see the ratio. If it's greater than one, then or greater is positive, greater than one, then it's C++ system is working better. And this is how we figured out how the system is how is going to be deployed. Next slide. And once we deployed the system over the last 1.5 years, we were able to make it much more reliable and maintainable with the really fast execution, which also provided a very good customer experience. We have observed 3 to 4 times better CPU time than the legacy Java system, and almost 2 times better execution time. And this is done with almost 60% of less hardware, or growing the throughput with almost 3 times. And today, all Meta's 70% of workload is running in this native engine. Next slide.
Awesome. Thank you very much, folks. Let me see if we have any questions from the audience. I mean, you're saying a decade worth of fixes in product development for Presto internally at Meta, right? Am I understanding you right?
Yeah, I think no, it's not internally, because the Presto is in open source, as Aditi was saying, so it has many functionalities within Meta and outside also. So to make sure Presto can be replaced with the new native engine, we had to kind of find the parity between these decade worth of work in the new frame platform, but within a short period of time.
Yeah. How far apart are they, and like how likely are they to continue to diverge? Right. Let's say like whatever version you guys need internally versus the one that's available open source.
I think there is no special internal version within Meta. There's the same version that we have in OSS, but there are some new functionalities there. But the divergence from the Java stack to C++ stack will be there are the machine learning file format support that are new, like Nimble file formats and other that are not available in the Java stack at all. Plus the regular expression and JSON libraries, these are practically different than what we have in Java.
We're getting a question here from Conrado. How long did it take to develop the drop-in replacement?
The development is still ongoing, but I think the Velox project and the Prestissimo project we started around 2022, so almost 2 3 years.
Yeah, we started around 21, so that's when I joined the team.
Yeah.
And we started this in open source, so this is like open source first development. It was Meta folks from like Ahana now at IBM. We had Intel folks and we had ByteDance folks who kind of started, and it's been going along for like 4-ish years. Yeah.
Yeah. We got another one from Yuri saying maybe Trino on C++. I'm not sure what.
Uh,
Yeah.
yeah. So of course, we are not trying that, but like kind of using Velox with Trino plans is, yeah, I mean, those plans are also close to Presto plans, so it's doable. And I believe someone did put something out in open source, but I mean, we've not tried it, so of course. Yeah.
We got another one here. Let's see. Rishab is asking, does it support GPU acceleration? So do we know, and do we know how well this compares to newer systems like Data Fusion?
Yeah, so the Velox layer is being enhanced for hardware acceleration as we speak, and there are a bunch of hardware accelerators. So there's NVIDIA working, there's somebody called Rivos, there's another Neuroblade, and so the accelerator, like it sort of comes at the Velox layer, and so like Gluten, Presto, sort of kind of just have to get that into their clusters. I believe. Gluten with Spark has done that already, and Presto is kind of getting there. Yeah.
We got one more here from Yuri. Another one deep in the weeds. Did you use Arrow Flight connector to connect the clusters between each other?
Uh, so we are not connecting the clusters together with each other with Aeroflight. It's not something we've tried yet, but we have our Aeroflight connector, and we are using it to connect to external systems.
Trino versus Presto, both are same or any difference in query engine? How Presto supports open tables like Iceberg, Delta table, and Hootie.
So I didn't quite follow. So the
Yeah, I'm not
query,
sure if there.
yeah.
Yeah,
So the
if you wanna repackage this as more of a question, I think it might be like Trino versus Presto. First of all, the difference in query engine there. That's the question.
yeah, so things have diverged quite a bit since the split between Presto and Trino. And like there is a lot of similar, so the runtime, of course, is different now because of Prestissimo. But in terms of the coordinator, we've put in a bunch of new things in Presto, like history-based optimization. I believe that's not in Trino. But of course, there's always a bit of sharing also that goes on. And the distributed execution, like the scheduler and all that, is still very similar.
Last one
But
here.
we added all the lakehouse formats for me to mention.
Okay, cool. I think that was the second half of that question. Last question here from Miron. Any metrics comparison between Presto and say Databricks Photon?
So those would be published directly by IBM. So we're kind of not going to talk about it here.
Stay tuned. Stay tuned, Miron. Amit and Aditi, thank you very much. We really appreciate it, and we
Yeah.
wish you best of luck